So now we're going to investigate something called the discriminant, which is an important part of the quadratic formula. So let's use a quadratic formula to solve these three equations that look very similar. Look closely. Their only difference is that last number. And let's see what happens. All right. So using the quadratic formula, we get x equals negative b plus or minus square root b squared minus 4ac all over 2a. So now we're going to simplify that there. We get square root of 16 minus 16 all over 2. And that's going to give us negative 4 plus or minus 0 all over 2, which is just negative 4 over 2, which is negative 2. So we get one answer here. All right, one solution, negative 2. Well, let's try this one. Looks a little bit different. So x equals negative b plus or minus square root b squared minus 4ac all over 2a. All right, let's clean that up. We get negative 4 plus or minus. We got the square root of 16 minus 12 all over 2. So we can simplify that. We get negative 4 plus or minus the square root of 4 all over 2. And we know the square root of 4, so that's going to be negative 2 plus or minus 2 all over 2. Since we can work the square root out, we're going to get two answers, negative 4 plus 2 over 2. And that's going to be equal to negative 1. And then negative 4 minus 2 all over 2. And that's going to be negative 6 over 2, which is negative 3. All right, so we got one answer and then two answers. And let's try this one. Using our quadratic formula, x equals negative b plus or minus square root b squared minus 4ac all over 2a. Now you might be recognizing a pattern here, some similarities and some differences. Here we have negative 4 plus or minus the square root of 16 minus 20. And what happens under the radical? It's going to give us a negative number, negative 4 all over 2. All right. Now that's an imaginary number, 2i all over 2. And we can simplify this here, make it into a form for a complex number. We got negative 4 divided by 2 is negative 2, plus or minus, and then we got 2 divided by 2. 2 divided by 2 gives us 1. All right, so 1i. So we have one solution, two solutions, and no real solutions. That is, one real solution, two real solutions, and no real solution. It's a complex number. So let's connect that to our graphs here. So here's the graphs of those equations. So notice that when x is negative 2, we have our x-intercept there. Because when x is negative 2, this equation becomes 0. That is the 0. When x is negative 3 or x is negative 1, we get zeros or x-intercepts there. So the solutions to this standard form equation are the x-intercepts. That's a big important thing to understand. So the solutions to ax squared plus bx plus c are the x-intercepts. Now, what happens if we don't have any real solutions? Well, there's no real x-intercepts. So this graph does not cross because we have no x-intercepts. Well, notice a difference here. What happened? Well, in this equation, we ended up with 0 underneath the square root. With this equation, we ended up with a positive 4. And with this last one, underneath ended up to be negative 4. Okay? So everything else was the same outside here. All that changed was what was going on inside. Okay? So at that point, when we work out the square root, that's when we realize we're going to have 1, 2, or 3. Actually, not 3 or no real solutions. You can't have 3 solutions but you can't have no solutions, all right? So that's when we find the square root of b squared minus 4ac. And so we have a name for that. That thing underneath the radical, that's called the discriminant. Okay? And so we have these situations here, all right? If it's a perfect square number, we get 2 rational solutions. Okay? And those solutions are the x-intercepts, all right? So 2 rational solutions. Rational means a fraction. It could be 5, it could be -3, it could be 2/3. Okay? If it's a non-square number, we're going to get 2 irrational solutions, because there's going to be a square root in there somewhere. All right? If it ends up being 0, then we'll get 1 solution, and it'll be rational. And if it's negative, we get 0 real solutions, no x-intercepts. All right, so it's important to kind of get that connection there. All right, so let's look at some equations real quick here and determine how many real solutions there are. So you don't have to figure out you don't have to solve the whole equation to know how many solutions there are. All we need is the discriminant, b squared minus 4ac. That's the thing under the radical. So in this case, that's -3 squared minus 4 times 4 times -1. And that's going to be 9. And this will be plus 4 times 4 is 16. All right? And so that's 25. So that's a positive number. There's going to be a positive number under the square root. This is going to be 2 solutions, 2 rational solutions, because we can take the square root of 25. All right? And we can check that on our graph. We'll go over here and open up Desmos. And I got a graph right there. And there's the graph. Okay, notice it crosses at 2 intersections. We don't care what they are right now, it just crosses at 2 places. That means we're going to have 2 solutions, 2 real solutions. All right, next, b squared minus 4ac for this one. And that's going to give us 2 squared minus 4 times 5 times 3. That's 4 minus 2060, right? And so that equals -56. That is less than 0. So that's less than 0. This one, by the way, here was greater than 0. That's why we had 2 solutions. Here, we're going to have no real solutions. Let's go check that out. I should write this down here first of all. This is no real solutions. All right. So no real solutions here. Let's see what the graph looks like. All right, so here's the graph of 5x squared. There it is. Does it cross the x-axis at all? No, it doesn't. So there's no real solutions there. All right, so we saw 2 solutions. We saw no real solutions. And let's see what's next here. We've got b squared minus 4ac, that is -24 squared minus 4 times 9 times 16. And, well, that's going to be 576 minus 576, which is 0. And so that means we're going to have 1 real solution. And you can think about what happens when that square root becomes 0. We don't have anything to add or subtract, and that'll explain to you why we have 1 real solution. Let's go look at the graph here. And there's our 1 solution there. Happens to be at 1.33. Okay, but it touches exactly once. Okay, so we have 2 solutions if it's greater than 0. No solutions if it's less than 0. One solution if it equals 0. All right, and we'll see one more situation here. We have b squared minus 4ac. That's the discriminant. And so this is going to be 5 squared minus 4 times 2 times 1. That's 25 minus 8, which is 17. What does that mean? Well, that means 2 real solutions, and those are going to be irrational. Because you can't take the solution, or you can't take the square root of 17. So if we were to work this out, we'd have 2 irrational solutions. Okay, so it's going to cross the graph twice. We'll have 2 x-intercepts here, but they're not going to be very nice x-intercepts. Okay, and when I say very nice, they're going to be pretty ugly decimals. Okay, all right, there you have it. That's the discriminant. Okay, well, the last little situation we'll look at for now is if we want to build an equation that has certain solutions. Sometimes we want to do that in applications. The key is this, to remember the zero product rule. If we know the x-intercepts, or we know the solutions are 4 and negative 5, we could build this equation here. Okay, we can factor that, build it out of factors. All right. So if we want to find an equation with these given solutions, well, if I want negative 4 to be a solution, then I need to have x plus 4. If I want 3/5 to be a solution, I need x minus 3/5. And that will be equal to 0. Right? And so that equation is going to have those solutions. If we need to, we can distribute that out. And then we can combine like terms in the middle there. This equals 0. And so, actually, maybe before combining like terms, what we probably should do is multiply this whole thing by 5. So let's get rid of that denominator. Multiply both sides by 5. And we have 5x squared minus 3 plus 20x minus 3 equals 0. And there's an x there too. Okay. And so in the end we get 5x squared plus 17x minus 3 equals 0. Okay. All right, that's the idea. If we know we want to have some rational, or some irrational, I should say, x plus 3 squared root of 2 and x minus 3 squared root of 2, that's going to give us irrational answers there, or solutions. So if we distribute that out, we're going to get x, we're going to get x squared. We're going to get minus 3 squared root of 2x plus 3 squared root of 2x. And minus 3 times 3 is 9 times the square root of 4, which is obviously 2. Well, these are going to cancel, and we just have x squared, and this is 9 times 2, which is 18. There's our equation. Okay. If you want imaginary solutions, well, we can do the same thing. X plus 3i and x minus 3i. Okay. And we can distribute that out. We get x squared minus 3ix plus 3ix. And then we have minus 3 times 3, which is 9, and I times I squared. Those cancel, and this is, remember, positive 1, I squared is positive 1, or I'm sorry, I squared is negative 1 times negative 9. That's going to be positive 9. That's where the positive is going. Okay, it's going to be positive in the end. That's what I was going for. All right. So it doesn't matter how many solutions you have, how many variables that is. Okay, so we have, if we have negative 1 as a solution, then we have x plus 1. 0 is a solution, so we have x minus 0 and x minus 2. So we have 3 solutions now for this one, 3 x-intercepts. And so this is just x times x plus 1 times x minus 2. And this is going to come out to be x squared minus 2x plus 1x. That's minus 1x. I'm going to skip a step there. Minus 2. And then we can just distribute the x. All right. So this would give us a solution of x cubed, or an equation of x cubed minus x squared minus 2x equals 0. So there we've built an equation that has intercepts of -1, 0, and 2.